Section 3.4 Linear and Angular Speed. Suppose that a point P moves at a constant speed along a circle of radius r and center O here. So we do have the radius r and create a theta. And then the point P will be here. P moves at a constant speed along the circle. And then we do have the arc length S in here. The measure of how fast the position of P is changing is the linear speed. If we represent linear speed, then speed will be equal to the distance over time. So think about what distance is talking about the S in here. The T will be the time. So V equal to S over T. And we call this is the linear speed. And one more time, S will be the length of the arc chased by the point P at the time T. Linear speed, V equal to S over T. As point P move along the circle, where OP rotates about the origin. So it's going to be moving like this way. The measure of how fast POB talking about the data is changing is called angular speed. Okay, angular speed, we're going to use the W to represent it. W equal to theta over T. Okay, theta over the time T. So we have learned two formula. One is the linear speed, V equal to S over T. Another one called angular speed, W equal to theta over T. And then the theta is always measured in radians. Okay, always measured in radians. Angular speed equal to theta over T. And then we have this formula, V equal to S over T. And then you know S equal to R theta, right? S equal to R theta. So we're gonna replace R theta with the S here. And then, can you guys look at here? The theta over T, which is gonna be equal to W. So we have another formula called V equal to RW. Okay, V equal to RW. The radius times the angular speed, that will be equal to the linear speed. Example 1. Suppose that point P is on a circle with radius 10 centimeters. And then the way OP is rotating with angular speed pi over 18 radians per second. Okay, so this is gonna be W. W equal to pi over 18. R equal to the 10. Find the angle generated by the P in 6 seconds. So the given T equal to 6. And you're looking for the angle, the theta. Okay, so since we know W equal to pi over 18, we're going to start with this formula. Okay, and then we know W equal to theta over T. Okay, W equal to theta over T. And we know T equal to 6 seconds. So theta over 6 equal to pi over 18. They will be equal to each other. So you could use the cos multiplication. So 18 theta equal to 6 pi. And then divided by 18 for both sides. Simplify it. So pi over 3 radians. Okay, we know the theta now. B. Find the distance traveled by P along the circle in 6 seconds. So I want to find the distance traveled by the P, which is going to be your S, right? S equal to R theta. And then R, that will be equal to, R equal to 10, theta equal to pi over 3. Plug it in. You should get 10 pi over 3 centimeters. Make sure you guys state the unit for your final answer. Find the linear speed of P in centimeters per second. Okay, linear speed, this is talking about the v, right? V equal to s over t. And then we already find s from the part B. T, that would be equal to 6. Plug it in. You should get this guy, 5 pi over 9 centimeters per second. A belt wants a pulley of radius 6 centimeters at 80 revolutions per minute. Okay, they say 1 minute, the pulley gonna turn 80 revolutions. Okay, 1 minute, they gonna go for 80 revolution. And then we know one circle, that will be equal to 2 pi, right? So we're gonna say that in 1 minute, the pulley makes 80 revolutions. Each revolution is 2 pi radians. Okay, so now let me multiply it. 80 times 2 pi, that will be equal to 160 pi radius per minute. Okay, 1 minute, how many seconds? 1 minute will be equal to 60 seconds. Okay, now we want to find the angular speed. So theta, that will be equal to 160 pi divided by 1 minute, which is 60 seconds. So divided by 60. You should get 80 pi over 3 radians per second. Okay, radians per second. Okay, B, find the linear speed of the bell in centimeters per second. Okay, again, per second. So we want to find the linear speed. We are looking for the V, right? It should be the same idea with the part A. And then we could use the formula V equal to RW. The R, what is the R? R would be equal to 6 centimeters. And then the W, we find it from the part A, which is 8 pi over 3. You should get 16 pi. Use your calculator. That will be 50 centimeters per second. A satellite traveling in a circular orbit 1,600 kilometers above the surface of Earth takes 2 hours to make an orbit. The radius of Earth is approximately 6,400 kilometers. Approximate the linear speed of the satellite in kilometers per hour. So we are looking for the linear speed. So first, we want to find the R. Okay, the satellite is gonna be here. So this is gonna be the radius. Okay, so we're gonna calculate the R first. That will be 6,400 plus 1,600, which is gonna be 8,000 kilometers. Right, we find out the R first. Okay, after we have the radius, then we're gonna see 2 hours to make an orbit. So it takes 2 hours to make one orbit. And then one orbit talking about theta equal to 2 pi. Right? Because they go one round, so theta will be equal to 2 pi. And we want to find the linear speed, so V equal to S over T. So first, we want to find out the S. S will be equal to R theta, right? R, we just find it, it's gonna be 8,000, right? And then theta, that will be equal to 2 pi. So plug it in. You should got 16,000 pi kilometer. Okay, then now we try to find the linear speed, V equal to S over T. And then it takes 2 hours to complete. So that will be the V equal to 16,000 pi over 2, which is gonna be 18,000 pi. It's about 25,000 kilometers per hour. Okay, so 1 hour the linear speed will be about 25,000 kilometers. Approximate the distance the satellite travels in 4.5 hours. Okay, we just calculate for each hour. The linear speed gonna have a 25,000. Now we want to find how about in 4.5 hours. So we are looking for the S. And then we could use the same formula. S equal to V times the T. Okay, V talking about here, the linear speed per hour. The time, that will be 4.5 hours. Plug it in. You should get 36,000 pi is approximate 110,000 kilometers. Okay, for these sessions, you do have two formula, linear speed and angular speed. For the linear speed, you may want to find out the S first. Okay, S is going to be out of data. That's it.